24, 24. So here's what we have here. This is actually quite simple once I give you the hint. You have two balls, all right? Here they are, and they each have a charge. One has a charge of +3 nanocoulombs, a billionth of a coulomb, and the other has a charge of -12 nanocoulombs. And they're 3 centimeters apart, or 0.03 meters, right? Don't forget to convert everything to meters. Now, getting the force here is quite easy. F E equals K Q1 Q2 over R squared. Plug and play. You've got all the information you need. Just remember to convert your nanocoulombs into coulombs, right? So you remember that microcoulombs were like times 10 to the -6. Nanocoulomb is times 10 to the -9. So it would be 3 times 10 to the -9 and 12 times 10 to the -9, which is actually 1.2 times 10 to the -8, I think, right? But it doesn't matter how you put it. You can put them in your calculator this way. It works the same way. It's not quite scientific notation officially, but your calculator will understand you. So that's the nanocoulomb part. Now here's the next part. The balls are touched together. So what happens to charge when two things touch? Well, remember what charge is it's a quantity that sort of disperses itself, and typically it disperses itself over the surface of objects. So if you have a +3 and a -12, then what's going to happen is those two charges are just going to sort of mingle all together. So when two things touch, we simply add the charges. And if you add them, you'd end up with an overall charge of -9. So now when they're touched, they behave as if they are one object with a -9 nanocoulomb charge. So you just have to know that. Now when you pull them back apart again, once you separate them again, now that charge has been all spread out. So guess what happens? If you split them apart, that charge will divide equally between the two. And you'll get a -4.5 nanocoulombs on each object. And then you can find the force again using plug and play. But unless you understood what happens when you touch them, that may have been the problem.